Have you ever watched heavy rainfall and wondered where all that water actually goes? What drives its journey across the land, sometimes gently, sometimes powerfully? Understanding this movement is key to grasping how water shapes our world. Surface runoff is the flow of water that occurs when excess storm water, meltwater, or other sources flow over the Earth's surface. It is a fundamental component of the hydrological cycle, directly contributing to stream flow, river discharge, and ultimately, the replenishment of lakes and oceans. Its primary mechanisms involve precipitation rates exceeding infiltration capacity and the saturation of the soil. The core reason behind surface runoff is a fundamental imbalance between the rate at which water reaches the ground and the rate at which the ground can absorb it. When rainfall intensity surpasses the soil's infiltration capacity, the excess water has nowhere to go but across the surface. Additionally, if the soil becomes fully saturated with water from prior rainfall or a high water table, it loses its ability to absorb more, forcing any new precipitation to become surface flow. This concept is often described through the Hortonian overland flow and saturation overland flow theories. To better understand these mechanisms, consider observing a local watershed after a rain event. Notice how different land covers influence the flow. Impervious surfaces, such as paved roads and rooftops, prevent infiltration almost entirely, leading to immediate and significant runoff. In contrast, vegetated areas with healthy soil can absorb much more water, delaying or even preventing surface flow. You can also analyze historical rainfall data and corresponding stream gauge readings to see direct correlations between intense precipitation and increased river levels, which are direct results of efficient runoff. Within hydrological modeling, the curve number method developed by the Natural Resources Conservation Service, or NRCS, is a widely used empirical model to predict direct runoff. This method assigns a numerical value, the curve number, to different land cover and soil types based on their runoff potential. Higher curve numbers, like those for urbanized areas, indicate greater runoff, while lower numbers signify higher infiltration and less surface flow. This granular approach allows hydrologists to quantify and forecast the impact of land use on water movement. In essence, recognizing the interplay between precipitation, soil characteristics, and land cover allows us to predict and manage how water moves across landscapes. This knowledge is not just academic. It empowers us to make informed decisions about land use, urban planning, and flood mitigation, helping communities thrive in harmony with the natural water cycle.
If you love learning about water, like, subscribe, and keep exploring with us.